and share the screen. All right. If we look at relations, like when you're done with this, you should always have a quick look into this little folder, because for some of you, I saw like all kinds of stuff in here, right? There were like a whole bunch of warning signs in there. There were types of constraints that we never used before, all that kind of stuff that shows up there, right? Like, people clicking on joints instead of constraints, those kind of things, right? So if you want to double check it, you can always see that here, right? So that's a good thing. But what I was trying to do is to tell you that now to do this, right, we have 1, 2, 3, 4 constraints that we need to put this in place. Right? It's easier to do if we use our 2 inserts. Constraint again. This one in. Right, this will be, we're basically doing the same thing here. Up there. Hit apply. This one. This one. Apply. And then we can do a flush. What that means is now instead of 4 constraints, we have 3 constraints. It's not a huge difference, but it decreases the amount of constraints we have, and it is the more natural one, you could say, right? The one that makes more sense, right? When we look at the way that we did it down here, right? We said, well, we're gluing these pieces to, the sides together. We're gluing, the peg into it. What we're really doing is we're putting that peg in there, right? And then just keeping it from rotating. So it makes more sense to use the 2 inserts and then the 1 flush. It works perfectly fine the other way around. I'm not going to take points off of that kind of stuff. But try to do it the way it makes the more sense, because that usually means you're using less constraints, and the fewer constraints you have, the easier it's going to be later on to figure out what it is that we're doing, right? Because if you go back in here now, see, well, what did I do? I have I have 100 constraints sitting there for a more complex part. Then you start looking for stuff and it gets difficult. All right, questions about this? Then let's do another one. Do another assembly so we can look at the new stuff. And let's just use the parts that we already have. Let's take 2 of them. So again, we'll add a spacer in here. Put 1 and the other one, and okay. And ground one of them. And now we can use all kinds of constraints on this one, right? We want to put them together. Let's do a line constraint. So we'll do a mate, but instead of using the sides, we'll use just one of the edge pieces, maybe this one and this one. And say, okay, right now we can have, it rotates on that, looks almost as if it rotates on that one edge, right? Here, see, it kind of goes up and down as if there were joints. Can't talk to it for some reason. Now, if we want to keep it from sliding up and down, right, we can do a flush here and here. And now we can, just like this. Right? Nothing that we haven't seen before. Right? Very, very straightforward. Now, if I wanted to put it at some location here, what's the next constraint that I should use? We have 4 different constraints at the moment, right? There's going to be an insert constraint. No, there's no circles involved. Is there going to be, what did I hear there? Angle constraint, right? If I want to keep this from moving up and down like this, I could use an angle constraint. Do that. Angle constraint, 2 angles, this surface and that surface, for instance. Let's say 45 degrees, just for it, right? And then I have it stuck on there. Remember that once we have that, we can go in, we can always edit that, right? We can say, well, we want to have it 35 degrees or something. That again, everything is what we did before. You can see both parts are now fully constrained. There's nothing that we can move around anymore. Now, if we want to have this move by itself, right, then we can do what we call a drive. If we right click onto the constraint that we want to drive, right, then we get a bunch of choices. We can of course edit it, but there's one here that says drive. So if we do that, then we'll get a new little box showing up. And it basically tells us it wants to play around with, like, the offset or here the angle, right? So we have here a start and an end angle. Maybe we'll start at 0 and go to, let's say 90, right? And then you have kind of playing forward, backward, skipping to the end, skipping to the start. So we can do that. And so it will move itself. So you tell it what the start location is, you tell it what the end location is, and then you let it roll. You go to the constraint, you right click on the constraint, like you just like you do right clicking on the sketch to edit it or something like that. And then there's an option that says drive. That opens up your new part, and then you add from where you want to do it, right? If we want to do it from -90 to 90, right, then it would go all the way through and back. Now you'll see these little double brackets here. Whenever you see those in Inventor, that means you can open up some additional part of your window. And the important parts here is that we can make it this first box here. The increment tells you basically how fast this moves, right? So if I say instead of 1 degree at a time, I do 10 degrees at a time, then it's just gonna move faster, right? Maybe here we want to go slow, we'll do half a degree at a time. The other thing that we can do is tell it how often we want to do this, right? So we can say we want to have this happen 4 times, but let's speed it up a little bit, otherwise we sit here for too long. But if we do that, then it will do that same motion now 4 times. Right now, this is a little strange looking motion, so we can change that. We can say we want to go start and start, right? So basically, it will move back and forth. But that means it only does it twice because each of those movements counts as one. Right, and that's how we drive these constraints. Now we can do that with any constraint that we want to, right? So we can say, okay, here we had the mate constraint, for instance. Give that a different view, right? So if I go into mate, if I do edit, then I can play with the offset, right? So if I say the offset is 10, for instance, right, it will basically slide, it will move it up and down from where the connection was, right? So now I could do the same thing. I can click on it. I can say drive. I can say maybe I want to go from 0 to 20, and it will move it up and down. Same thing there. I can tell it to do it a whole bunch of times and to start, and it will do that. Same with the flush constraint. Where do we have drive, right? So the flush, that would mean that the 2 plates are together, right? So I can move them basically to go apart. Do 20 here as well, right? And so it kind of, the flush was between the front and the top one here. So the flush and the mate basically are creating the same action. And let's go back into here and change that back to 0. So let's set together. Now that's all fine and good, but how do we capture that? Right? We can make these little videos. Basically, they're there to show you that how stuff would be moving. Right? If you have, for instance, in our toy truck, right, it will show that kind of the assembly where the ladders goes up and down, or turns around, or extends and comes back. So those kind of things, right? So if we want to capture that, then we have this little red button here, the record button. So we hit the record button, it will open up a whole new window. Let's say, let's go back in here. That's put here, that's fine. And then you can choose either, like there's 2 file formats it will allow you to do. We'll do the W and V first. give it a name, you give it a location, you say save. I really love the way that it sets up kind of how detailed these files are. They're by how fast your internet connection is. And even the most fancy one is not all that great. Right, so I'm not sure why they never updated this. Right, this has been the same for over a decade. They should probably go from a little higher resolution by now. It doesn't. You say okay, and then what you have to do is you have to hit play. Right, so it will basically record this motion. You can change the perspective if you want to, and it will just keep on recording. Once it's done, pops this up, and then we leave this window. And now let's see if we can find where we want it to go. There, and you see this file showed up.
What's the type of file?
It's a WMV file. You can also do an AVI file if you want to. The AVI file, as we'll see, has the great advantage of actually looking good, right? Depending on what your computer is. On my laptop, this looks a lot better. We don't get the nice 80s color scheme in the background. But this is just because it's very poorly resolved. But you'll see that you know we can see this for what you're doing. If you want to send me these videos that look a little funky, that's totally fine. But you will see that once we change the perspective, it reflects that in our system. All right, so that was our first file format. You'll also notice that these run along a lot longer than what it is they run on in here. All right, let's do the other one. Drive, record. And so if we wanted to use an AVI file, does the same thing. Now it allows you to basically choose how compressed you want to have it. If we just go uncompressed, do the same thing. Now this is going to run pretty slow because it takes a lot more time to capture stuff as an AVI. Move stuff around while we're doing it. Back to the original view. And you know, should have reduced the amount of movements, but we'll just wait for it to finish. Now, when you're doing this, it's especially with the AVI file, it is important that you close the little window that pops up at the end. But if you don't close the drive window, then it will not release that file. So it will hold on to that file. You won't be able to find it anywhere. So you have to hit the kind of the OK or the cancel button. Just to get some more perspectives here. I hope this is the last one. There we go. So we'll do cancel. Sometimes it takes a couple seconds to show up. This time it didn't. But you'll see it is quite a bit bigger. All right, so these files can get very big very fast. So please don't try and post those on Blackboard. It's going to be a disaster. But you can see they're also much nicer, right? It's captured it the way that it actually looks like, not the way that not with that colors. But that's it, right? That's all we have to do to capture these videos. They're very simple to do. And with that, I think I had another example to do here, and then you can do not the in-class yet, lecture. Let's do, where are we? Number 18. Do another example. That. Just open. All right, so we're going to try and create this part right here. And as you can imagine, this top kind of system will be able to move. All right. We're kind of given what it's supposed to look like. And then we're given the part dimensions, everything that we need to know. Now, the tricky part with this is one of those where there's a whole bunch of dimensions that are missing on these. So we'll just have to make them look as if the way that we want them to look. Let's zoom in on this one a little bit. So we'll have to do a couple parts. see if we can have that part right next to us. Something like that. So we'll start with a new part. Exactly in the wrong spot for me. Standard part, create. And so of course we're going to create this, the bottom piece first. That's the most complex part. So it is 160 in this direction. If we kind of start with the bottom piece, 160 in this direction and 30 in the other. So that's straightforward to do. We said 160 by 30. And we'll zoom to what our part looks like. And then we need to put all these holes in there. We can put that in there right away. The first hole, so like one of the things that's missing, for instance, is the diameter of these holes. So we'll just choose something. So this would be our front edge. We'll put our first hole somewhere here. And we'll say maybe that's an 8. I don't know. It looks a little small. But it tells us exactly where it's supposed to be. It's supposed to be 19.4 from the back. That should be 19.4. And it's supposed to be 796 from that edge. It's a little strange as a number, but that's okay. 7.96. There we go with that one. And then, of course, we need a whole bunch of these. We need 1, 2, 3, 4, 5, 6, 7, 8. And they're all 20 apart. So we can do our rectangular pattern. Choose our direction. We want 8 of them in total. And we said they need to be 20 apart. And with that, we have them. Then we can also, before we extrude, we can cut these corners. Doesn't say anywhere what those are. It says up here it's radius 12, so let's do the same down there. 12, here, there, and there. And with that, I think our bottom part is done. So we can then extrude it. It's supposed to be 8 in that direction. Eight, and then we can put the back on there. Now it doesn't say how tall the back is. I looked, at least I couldn't see it anywhere. But it looks like, you know, probably about another 30 going upward. So we'll just do another sketch. Appears that it's not so important for them to know exactly how tall this piece is. Rectangle. That part is supposed to be 10 wide, so we'll put it right in here. And we'll say, so 160 is good. 10, not 8. Finish that one, and we're going to say it's 30 high. So let's extrude this by 30. All right, let's swing this around so we can see. So what else are we missing? We're missing the big holes, and we're missing the text. So that's all good. The holes are on this surface. So sketch. And what do we see? So they're supposed to be 138 apart, and we don't know how high they are, but we know that they're tens. I'm sorry? What about the fillets? We can do those too. Yeah, I was going to do those after. The holes first, because sometimes when you like, the reason why I like to do the holes before I do the fillets is that if the fillets come down too far, then it might be difficult to get the dimensions because you don't have a straight line anymore. But you can find ways around that as well, I'm sure. So these are supposed to be tens. And they're supposed to be 138 apart, and we'll assume that they're centered. So 138, that means there's 22 to 160, so 11 on a side. And looks like there maybe let's do 15 to the bottom for no particular reason. I'm sorry?
One of the vehicles taller than the other.
Looks like it, right? Looks like this is a little higher, but there's no, again, doesn't show any dimensions for these, so it's a little annoying.
And the center needs to be the side, like the right.
True. The two, it doesn't give a center line for some reason, but the two hidden lines are off. So that would indicate that they're a different height. So if you want to put them at a different height, we can put them at a different height. Put our second circle over here. So this one would be a little higher then. Radius is a 10 though. We know that the distance to the edge needs to be 11. Did that one 15, so what do you want to do? 17? 16, 17? Nope, not 170. Now it's a little higher. In the end, it doesn't really matter. Then we'll finish so we can punch those holes in. One, number two, other direction. Very good. We can do our fillets up here. These are supposed to be radius 12. Keep that a little closer. 12 there, 12 there. That's good. We can do the fillet down here. That's supposed to be R3. Much smaller. There we go. That's all good. So the only thing that's left is our text. And where it's text, right there. Can move it around later. What was it? Old amalgamated. Old. Amalgamated. Now that's too small. Let's do it 8 maybe. That's something I find very annoying when you go in here. You have to actually highlight the text that you want to change the font of. That's about right. More or less centered. That's good enough. And then we want to away. We want to cut it in. Let's do 2 millimeters. Choose our profile. Choose our profile. And there we go. I think that is everything, right? That looks like our part here. Other than that they shiny it up. Yeah. All right, very good. So let's save this one. Let's do a new assembly. We have assembly 3, so assembly 4. And that was called what? That was called the base. All right, part 1 is done. Then what else do we need? We need to have a whole bunch of these. Now you can see that this is 3 parts basically that are all defined within this one sketch, right? The only difference is going to be what the distance between these 2 center points is. So what we can do is we can create a new one. And then do another sketch. And now how do we do this best? Maybe we'll just do the 2 circles and go from there. So start one of our circles. The inside is a 10. And the outside is an 18, right? What were you saying?
No,
Right, because it's very important. This is given as the radius, right? So for our full circle, we would have to do a 10. Now we can do the same thing with another set of circles somewhere up here. The inner one was 10. The outer one was 18. And we know that that dimension, the distance between them, is supposed to be 50. All right, so this, of course, does not quite look like what we want. So let's do a rectangle. Somewhat like this. Doesn't really say what the size is, but let's do the same size as the inner circle for no particular reason. And then we need to trim around a little bit to make it look nice. So we need to cut this, this, and this, this, and this, and this. And does it say what the R5s? 5 here, and there, 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 there. I think with that we have everything we need. Finish. And it's supposed to be 5 wide. All right, so that's our first of our multiple parts here. This was called the crank. So the crank. There we go. And now we have to do the same thing for the follower and the coupler. Now, we can, of course, because all it changes is this distance, right? We can just take what we have here and just change that distance. But before we do that, very important that we need to save it as a different name then. Otherwise, we're just overwriting it. So we give it a new name. We call it the follower. There we have the follower. Now we go in here. Now this can be a little, does not always work the way that we want it to. Let's see what we have, what happens if we just go to 80. There you go, already did something that we didn't like. Or we can, usually we can define this to be 10. That might also help. Not what we'll try your suggest. There we go, that worked. Right, to keep that in place. So sometimes you have to add a little extra extra parts to it, but it's still faster. Even if I have to add a dimension, it's faster than redrawing it. We'll save this one. We'll do another save as. What was the last one called? The coupler. Save, same game. And sketch. Now this time it shouldn't do anything because we already fixed it. 160. Looks about right. So let's not forget to save. So we have those parts. That means we have these pins left right here. Part 8. And I guess I probably just draw this the smaller one and then just add the big one. So the small one has a diameter of 10 and gets extruded to an overall height of 12. There we go. Now we kind of have to draw this ring in here. To do that, I suggest we just do a plane with an offset. Have that one here. It's supposed to be 5. Arrows going down. We want to go up, so -5. Do to our new sketch. Same center, and this is supposed to be 14. And then we need to be 2. Exactly, right? Because we have 5 top and bottom, 2, and it has to go up. Thank you. And there we have it. Let's not forget to turn off our work plane. And that's our part right there. So we can save that one as, let's say, a 4 pin. Say pin 4. And save. If we look at the other pin, it's basically the same, it just has a longer bottom part. Right, so basically, it has 10 at the bottom, where this one had 5, so we'll do the same trick. This one was called a pin 1, right? So we can say save as pin 1. And then there's probably many different ways we can do this, but I think the fastest is just circle down here. 10. Extrude for another 5. And save. And with that, we have all our parts, right? So that means we can now scroll back up here to see how we're supposed to put together. So we'll use this as our base and then just add stuff. So we need is an assembly. Standard millimeters. We want to place our base in there, which was base. Let's turn it around the y-axis. Another time around the y. There we go. Good way of doing it. All right, so we have our base. Make sure we ground it before we do anything else, so that gets forgotten. Got a little pin. And now we're just going to put all the different pins in there. So we'll place the pin 1 was the longer one, so we'll start with that. 1, 2 of those. All right, do those, of course. Shove all the way over there. This one and that one. And apply. And this one, that one. Remember that, like, whenever the arrows show you what it's going to be sitting on the top, or is it going to come from the inside? Both of those look good. Let's flip this around because we'll need to see those pins, and then we can put in the crank and the follower. Crank will be over there. Start the crank. There we go. Another insert constraint there. Right. Then we need to place the follower. Do the same thing here. This one and that one. And okay. And then we need to place the other pins. Is there a question in the back, or? No? Then we'll put those in too. Let's scroll up to see how they're sitting there. They're sitting towards the back of it. Some more insert constraints there. So in the past, something that's amalgamated is like a whole bunch of stuff stuck together, is the meaning of amalgamated. A lot of bigger corporations in the late 1800s, early 1900s used that in their name when they were multiple different operations together.
It's like
So
incorporated.
a little bit, but it's more kind of a descriptor than what corporation is. So a lot of So the famous one that is out there is Amalgamated Steel, which was a massive company in like the early 1900s that just had all kinds of different, that produced all kinds of different steels. And so they had started as different smaller companies, like, you know, Jones's Steel Factory and whatever, Hudson Valley Steel or whatever, and they all got together, and as their new name, they then said, well, we're just Amalgamated Steel. And let's put this one, apply, and the same for this one.
Can we export a piece from Inventor into an STL file?
Oh, of course. How do you think I've done all my prints? Huh? Yeah. I'll show you later, like once we're done. So the only piece that we're missing is the coupler. Now you'll see when you do these kind of sets that are all together, and then they lock as a geometrically. Sometimes it's good to have them come together in the way that you want it to look at the end, because sometimes you put them, basically you would have the main part sticking down here, and then the other parts can't move, and so sometimes you have to kind of play around with it a little bit. Constraint, another insert, that one, and then of course the same at the other end. Now when you're, if I were, for instance, to try to put this end and that end together, right, then it wouldn't allow me to do it, right, because I would have to twist the whole bar to get it into place, right? So I'd have to choose other ones. Let's do cancel, insert, but I want to take the outer circle and that one, flip it around, and it's the way that we want it to be. Right, so now if I move this, it will move around. All right, but of course we don't want this to move around, right? Whenever we have these assemblies, we want them to be completely constrained. Nothing is supposed to be moving around. So what type of constraint am I going to use to keep this from moving around? Remember, you have 4 different ones, right? Definitely not an insert. There's, sorry, angle, right? It's not going to be a mate. It's not going to be a flush, right? Because there's nothing. I mean, I could do something like a flush, maybe this one and that one, but an angle is definitely the right one. Plus, it's going to help us when we do our drive. So let's do an angle between, for instance, that and this, right? And now everything is nice and unmovable. All right, but we wanted to do drives, right? So we can do that as well. We can go into our angle constraint here, and we can say drive, right? Again, right click on it and then drive, and then we can say we'll go all the way around, so 0 to 360, and that one didn't work. Didn't like it. It can't actually go 0 to 360, right, from its geometry. So we'll say, all right, that was unfortunate. So what we'll do is we'll delete this one. Now we can move all around. So if we move this, right, we can see that this one actually can move all the way around. So let's do the constraint there instead. Here, move that so we can see the surface. So we'll do again, angle constraint, that one, angle constraint, 2, this one, and okay. And now we'll try the drive. So again, we'll right click on the angle, drive, 0 to 360. And now it kind of moved. Something went wrong here. Oh, we put it on the wrong side.
Yes.
So what we have to do is we have to find, right, this should be on the back, not the front. So all we have to do is find where our constraints are on the coupler. So this one we don't want to. We want to actually go to these 2 pins and get rid of those. That insert there. Delete. That insert, delete. Now we should be able to move this around. Perfect. So now we can do those constraints again. Constraint, insert this one and the outside one. Lie. That. Now, if we go back, drive our constraint, she'll be working fine. But we're no longer crashing into ourselves. Nope. All moving perfectly fine. On the slow side. Speed it up. Let's have it do it a couple times. And that's how we do it. Any questions? All right, it's pretty straightforward. Of course, the worst thing to say because I didn't. So with that, I will let you work on your own stuff. Where is right there? Assignment. No, you're not. That's the big problem. So it's not set up to run multiple or to drive multiple constraints at the same time. So you can only do one constraint at a time. There is a way that I have not tried out yet. There's an extra piece of software that you can get, which is called Studio, that allows you to do more animations at the same time. But for us, it's really just showing like a certain aspect of what's happening. The only other animation that we'll be doing is within the presentations, right, where you kind of see how the assembly slowly rips itself apart. All right, so what I want you to do is this assembly right here on the end that's kind of similar to what we just did, right? It has a base part and then a couple different links that are all together. Be careful, this is in the book. There's a couple typos in it. So the parts that are in red here, so they flipped some of the pegs around, right? Didn't make sense the size that it had. Everything is given to you. You have to draw these parts.
I have a question.
Yeah.
That part, can you explain it?
This one?
Yeah, I'm not sure what the thickness. Like, not the thickness.
The width right here.
Yeah, there.
The width right here is.
It says 12 TYP, but I'm not sure if that's like what TYP is.
I think that goes all the way around the 12. So 12 here, 12 there, 12 there.
What does TYP stand for?
To your pleasure.
Thank you for venturing.
Said it better than mine.
Okay.
That's a good one. I have to write that one down. But it's 12 and all around. So let's get going. This part is going to take you a little bit.
Yeah.
Yes.
It's not an easy part, but it's good for you to practice to do some parts.
Oh,
It's cracking my
is
brain.
this, bueno, am I supposed to upload this one that looks like?
I don't know, it's kind of hard to see if it's lying on the table.
It looks there.
Yes, but if you do it as an ABI, it's not gonna, Blackboard's not gonna be happy. There's many different ways of kind of going about this part. I think most, like the easiest ways are kind of to start with the centers of these circles and start connecting. Very important to see though that the center of this circle right here is not at the same height as the other.
Yeah.
There's that offset.
I have a question. Like, there's an R10 and an R15 in that same circle. So the interior.
What you can do is you can, like this circle here, for instance, tells you where this line is, right? So basically what you can do is you can find where that location is. You can draw a circle with the diameter of 20 to use for down here, and a radius diameter of 30 to use for that part of it. And then, of course,
Where would you start?
I think I usually start at that point right there. Right? If you have this point, you can draw this first big circle, that circle, you can draw that bar going out there, right? Because the center line is the same center right here, so you can draw that one out.
What's the thickness of the bar?
12.
Oh.
Right, and it says that it's kind of it's at the center.
Oh.
Right, so once you have that, if you wanted to, you can draw yourself a line that goes at 45 degrees into a mirror, or you can just draw the rest as well. Now, one thing that you will notice once you get to these points here, right? Be aware that the dimensions are given at an angle, right? It's not 40 this direction, it's not 40 that direction, it's 40 in this direction. 45 degrees? That is 45 degrees, yes. But don't do two different, like, 40 times square root of 2 over 3. Right? Because that's not exact. Right? You have to figure out how to do it like this.
A 45-degree angle, and then
How to do it. When you, again, what I would do is I would start with this circle. You draw out what this is, right? Once you have this figured out, you can draw this one up with this circle, then you can just do a straight line.
Yeah.
And do an offset of that line, and you have what you need.
Tranquilo.